So now, not just to beverage. So now I'm getting a little bit out of just the beverage and bottling, but more most of manufacturing, especially when I have a production line in CPG. The highest ROIs that I see, it's usually on utilities. And I did want to talk a little bit about this, So what I call the top energy consumers, right?
Yep.
I like going straight to, when you talk about energy, a lot of people go straight to electricity, but just remember that steam, compressed air, other things are also energy, right?
Steam, compressed air, gas. Yeah.
Right. And now this is something that I failed in the past. And if I was adopting a unified namespace, I know for sure this could have been a lot better, which is, for example, this one. I'm trying to correlate how many gigajoules per ton of product. This was a good metric. But energy, we have a lot of power monitors, 500s, GE, Multilin, and all that into one silo. And then we had production data in another silo, right? And it was very difficult to integrate these two. So we had to use OLEDB and go into iFix Historian using a SQL bridge and doing all this kind of spaghetti because we already have point-to-point connections. And after a lot of extra programming, I got it. But at that time, I didn't know about unified namespace and especially how we could solve this problem using MQTT broker. That would have been a dream.
Yep, and I do one piece there too for some people who might watch later or during. The MQTT broker and the unified namespace is going to do a really good job of your overall values for various energy readings. You're still going to need a lot more of the more traditional, more complex, often vendor-driven solutions for some of the full scalar data, the full spectrum stuff that for real deep analytics. But you can solve so many use cases with just the overalls from very simple measurement tools that really work well with the UNS.
Very good. So I think electricity is what I call the primary because you kind of derive compressed air from electricity, right? So your compressors run out of electricity, right? Again, I think gigajoules per ton is a good metric that I see quite a bit. Back to Zach's point, Zach was saying, hey, I want to see this OEE by product, by SKU number. That is also a good one. So now I'm saying, hey, when I'm producing a half liter versus a full liter bottle, which one takes more, is it linear, right?
Yep. And I want to jump in here too, because this is something that a lot of people think is really hard to do. But a lot of facilities, especially if they're already running on VFDs for a lot of their pumps and their motors and their compressors and things like that, this is all data that's usually really easy to get out of existing VFDs in various forms.
As long as they are in the network, right?
Right. But it doesn't always take putting massive, very expensive certified meters on to solve the use cases we're talking about here. There's a lot of things that the big certified meters can do that these can't. And then for things that aren't connected, there's always things like the Opto EMU and other power monitoring solutions as well that are easy you put your clamps around your wires and move on from there.
Nice. Yeah, less invasive.
But it's a much easier use case than people usually give this credit for.
Is on this one here, for example, when you talk about like sleep mode for conveyors, right? Yes. So if you don't detect that the product's not coming down, put that on sleep mode. Just like when you go to an event or to pretty sure that Prove It last year, when you're not on the escalator slows down, right? So now I don't want to get too deep into it, but I've seen the same customer installing new machines without VFDs in the network. So now it becomes a strategy and disalignment. And they don't have VFDs on the network, right? Because it's cheaper, engineering is doing that. And then digital comes in later and decide to add network. which would have been much cheaper if you would have done it from the beginning, right?
Yep.
And then they do the same thing.
It's not even just VFDs either. I mean, a lot of your smart overloads or your motor starters can do this as well.
Can a soft start do regen though?
It depends on the soft start.
This is what blew my mind with wastewater is they'd pump, millions of gallons of water up to 100 feet, 200 feet. Like they're storing energy and they're not capturing any of it on the way back down. I'm like, dude, you guys, what the hell?
That's right.
Yeah. But a lot of places don't even know that, let alone how to get to it or what the data is. I mean, if you know that it's running, you can do a lot by just seeing that data.
It's literally a battery. Like, what are you guys thinking?
Which that one here, if I go a little bit down on this one, this is one that I love, Zach. Talking about reusing energy, right? If you have stored energy, in this case, you're talking about water as energy. This one for cooling tower is bottling, right? Especially on carbonation. So we have these things that we call the combi lines, which is the blow molder combined with a filler. And then you blow the bottles. And then right after, you need to cool it down. But to cool this bottle down or to wash, I think on the Enterprise B, we have washers there as well. So you don't want to wash that bottle with a high conductivity water from tap water because it's going to leave a film. So usually you have low conductivity, you already passed through RO or reverse osmosis, and then you're washing bottles at 40 GPM, for example, right? That nice clean water is going straight down to the drain. And then at the same time, you're running cooling tower, which is basically a big pot of water that you could use the low conductivity water to go back there. You know what I mean?
Probably put a heat exchanger too on it, like a heat pump or something to capture further energy too.
Yeah. So we do a lot of that. So once I start learning about regen, because we do these hot water sets and pasteurization, this is very cool. So you heat it up. So you have a plate heat exchanger, for example. One section is heat, the other one is cool, the other one is regen, right? Because you can cool down preheating with the preheated water that already passed it through. You know what I mean? So you can, it's called a regen section of the plate heat exchanger, which I think it's always fascinated because you have like 20% is heat, 30% cool, and then you have this. Most of a plate heat exchanger is regen, All right. I think we have time here to go through a few more. I think sorry, go ahead.
Plenty of time.
All right. Just wanted to do a time check. Again, because this is experience that I have as use cases, and we can talk and come up with these use cases together and help the customers this way, right?
Yep.
Supply and demand in compressors. So what I see a lot is that I get to a place, compressors are running on manual mode, full throttle, and maybe today just half of the lines are working, right? That can be, you can manage that supply and demand with all the compressors in auto, and then you do a good sequence startup and shutdown sequence in there. Only if it was that easy, because and then you learn that with that utility guy, the factory never stops.
Right.
Because he knows that 2 more lines are coming up. And he anticipates, he goes there, and then he starts 1 or 2 other compressors before it's time. And this tribal knowledge, he never transfers to anybody else or let engineering know. And then the day that he takes vacation or he retires, the factory doesn't run as well.
Right.
Right?
That's, again, why it's important to be logging all this, so at least whether or not at least you know.
That's right. A good point, because if you're logging this data, even if he didn't tell anybody, you could look back at this data and say, wow, it was doing better because these two compressors were coming up in manual right before the machines went online.
If he retires and a month later it's not running well, you do your root cause analysis. Why is this machine running worse than it used to? Follow down the events, and you'll probably get to the fact that he retired, and that date is when things started to change. But then you can keep going, and in the process of that, you'll have seen all the different data points that you used to get there that you can then use to recreate what was done without needing to try to call him back in or try to pay him as a contractor or something to get him back in to teach others. So a best case scenario is still having the people cross-trained, and obviously the culture is the much more important piece here, but even in absence of that, this gives you a little bit of a safety net.
Yeah. And I think you're going to agree with me where I like when I'm doing a project, engineering is leading, I like going down and talking to the operators. Right?
Yeah. I know it's common, but I still can't wrap my head around people who don't do that.
Yeah.
I mean,
sometimes they kind of don't let you, they say, no, I can handle everything. And then I have to be a little pushy, say, hey, during commissioning, can I stay there with the operators and just hang around? I just want to be there.
Yeah.
And then I learn a lot.
Yeah. It's more of a requirement on our side, but
nice.
Yeah. If I can't talk to the operators, if I can't train them, I'm the unusual, even like when I was doing like raw controls engineering and PLC code and stuff, if I was down there on the floor, I preferred when the operators or the other engineers, the maintenance staff was over my shoulder looking at the code and asking questions and why does this work or why does that work or why'd you do this, or being able to explain to people kind of how things are happening or why are we making this screen. And without that, you're never going to get the user experience that you would otherwise want. You're not going to get the training. You get a lot more service calls after the projects are done. And people are generally just not as happy. Even simple things like watching what buttons they press on the HMI and where they're positioned on the screen and just making little subtle changes based on what you see people doing or not doing. The ergonomics are very important. And if you're not watching and you're not talking to and you're not at least being friendly with and working with the operators, you're never going to know the requirements for that.
Yeah. A good one that I had there was... we had to start a hot water set when we start a pasteurizer, right? And then we were doing commissioning pasteurizer number 2. And then I'm there on commissioning. The operator says, well, I'm going to start the hot water set. And I was like, why? According to engineering documentation, the way I programmed is going to start automatically. But he says, I just heard the hammering from the receiving. So I know they're going to call me up because the receiving tank is full. So I'm just getting ahead of the game. Otherwise, I have to spend 15 minutes.
Oh, yeah. They know what they do. They know why they do it. And as I said before, the data can be a good safety net, but it's not a replacement. Right. The data will tell you what they did, but it won't tell you why. And sometimes you can kind of find why by looking through it. But usually... what you can find in 8 hours of looking through the data, doing a bunch of machine learning and fancy algorithms, you could get in 5 minutes of a conversation with the operator who actually made that decision. It's why you can actually
make changes and get value, which in this case was the trigger now for the hot water set is no longer the HTSC starts, but is when the receiving is done. So receive shut down, the tank is over 80%. I don't remember, it's been a few years. Now it's consistent. Now everybody does the same. There's no operator that goes there and does something manually, saving a lot of time because they receive that maybe 3 or 4 times a day.
Oh yeah.
So
there are things that you just can't find through the data too, that no matter how much you want to, you're never going to be able to track. Right. There was one I went to and it was all good with the product they were running. It wasn't any problems with recipes or safety or anything like that, but you could tell that it was a big block press and it was running better sometimes than others. And you could kind of figure out it was this operator or that operator. It would work better at different times of day, what correlated to which operator was on staff. And nobody really knew why it was doing this or why it wasn't doing that. And when you walked out to talk to the operators, they would explain, when this sensor hits this, it does this. It sometimes gets stuck there, but it doesn't do that. And then you go down that rabbit hole that isn't always the best rabbit hole to go down, because everybody's going down this big technical rabbit hole of sensors and actuators and timing and all this stuff that they're changing with whether it was the hydraulic press or timers and such in the PLC code or adjusting sensors. But the real difference of why it was working better or not was they had a can of cooking spray that they would use to spray down the chute. And some operators used it more than others. And you would never know to track that.
Crazy.
You would never be able to track that.
Right.
But when you're there talking to them or even just watching them, you can see they're picking up this can of cooking spray, canola oil, Pam spray in the metal chute under the block press, and it would get stuck less.
Nice.
And you're never going to get to that root cause without actually talking to the operators, watching them work, working with them, and learning the machines as they know them.
Or nowadays, putting a vision system there with AI and spy on them. So that's a little weird.
You know what I want to do?
Yeah.
I want to
Say
buy an Opto 22 EMU, electrical monitoring unit. I want to install it for free at a manufacturer, like nearby Salt Lake City. Like, hit me up if you're spending like more than like $10,000 a month on electricity or something. And then just collect the data and then let an MCP tool and AI recommend changes for improvements. And then at the end of the year, you know, compare energy savings and then like have like 20 or 30% of that energy savings as payment.
Right.
Yeah.
Now you're putting, that's how much you believe,
That's the
right?
Alex Hormozy, like the offer is so good you can't refuse it. Why would you not?
Right. So you're
other
taking
guy
the
is
risk.
gonna do that.
That's an entrepreneur there taking the risk. Say, hey, I believe in this, you know, and I'm willing to take the risk and getting part of the reward, huh? I like it.
Yeah.
What are you guys most excited about for Prove It?
Besides
Think
medieval
about that.
times.
Let's finish the
Let's finish the slides
topic,
here.
but let's end with that.
Yeah.
One through
Okay.
one.
I have a very few here that I wanted to talk
Yeah, we
about.
got a few
And-
more.
And again, these are all real things that I've done, right? So high pressure bleeding into low pressure. So now you're creating energy to waste energy, right? So sometimes they have the compressor for high and a compressor for low is so much more efficient to actually run a low pressure compressor than losing in here. Shut off in idle time. This is a good one because they wanted to have the blow molder manufacturer accountable, and they were saying, I don't need a shut off valve in there. And we were saying, hey, if we put a shut off valve in there when the machine is in idle, and then you don't have more air leaks. But while you're fighting this battle, I think it's such a low-hanging fruit, you know, putting a shut-off valve in machines that don't run very well, right? Again, and others, what I always say is about a lead and lag indicators on everything. And I think here's when Unified Namespace, you're talking about real-time decisions, real-time dashboards. And do you want somebody to let you know how bad you did yesterday or how bad you did last month? Or do you want to see where you are now and what lever can you pull to make improvements, right? And on this one here specific is a cooling tower, right? Which maybe for next stream, I have a cool presentation about how to manage a cooling tower. And a big mistake that I see people doing is installing power monitors in there and trying to measure cooling tower efficiency by how much energy it spends. And it's not the metric you should be looking for. It's what's called cycles of concentration. Is how many blowdowns you have. Is the conductivity you're accumulating. So you have specific metrics, and you most likely have that data. because if you have a blow down valve, it's probably doing blow down by conductivity, and all that kind of stuff, this kind of data you already have, probably you just don't have the metrics